My name is Panickos Neophytou. I'm a co-founder and CTO at NetBeez. And today I'll be covering with you the NetBeez wide area network and enterprise Wi-Fi use cases. So if you're someone building and managing a campus area network or have many locations distributed around the world, this presentation is going to be of interest to you. So for the purpose of the wide area network and enterprise wireless monitoring, we developed a multitude of different agents and sensors that can be deployed literally anywhere in your networks. So first we have our hardware platform. It's a wired sensor that is a gigabit Ethernet sensor for remote branches where infrastructure is hard to find. So it's for places where you cannot really deploy a virtual machine. So it's easy plug and play. You can use it with a PoE or an external PSU power supply. And then we also have our virtual and Docker agents that can be used either in your VMware environments or virtualization environments or any kind of server that Docker supports right now, but also you can use it for integrated switches and routers, which is perfect for locations where you have your Cisco Catalyst 9300s or any extreme networks and so on. And we also provide our cloud agents, which can be deployed on Amazon, Google Cloud, Azure, any type of public cloud environment. So once you deploy these sensors, you will have the ability to measure end-to-end network latency, packet loss, jitter, and MOS estimates. And now these are the latest, like jitter and MOS are the latest metrics we have added recently to our arsenal to help understand the user experience for voice and video calls, especially now that the popularity is going through the roof. So this test will give you a continuous view of the jitter and MOS of experience of the users in the remote locations. Moreover, other than the continuous monitoring tests, we also have throughput tests, which can be scheduled in regular intervals. And they can perform agent-to-agent throughput analysis using iPerf, but you can also do a network speed test using NDT and fast.com. And then the sensors can also give you insights about the network topology to understand bottlenecks by visualizing trace route data, and then coming up in the next quarter with ECMP visualization. All right, and then on the enterprise wireless network side, we offer an integrated hardware sensor that supports 802.11 AC. It has integrated power over Ethernet or external PSU power supply, and it can monitor up to 4 SSIDs by hopping through different networks in a round-robin fashion at regular intervals. And so while the sensor is connecting and disconnecting through the different networks, it measures the Wi-Fi connection timing, and it breaks it down by association time, authentication time, and DHCP, and you can view those in a timeline, and you can understand what is the performance of your Wi-Fi network authentication backends and so on. At the same time, while
sorry, I have a question for you. Does this also do any spectrum analysis or anything like that, or is it just association time and flight time of the data?
No, it's just right now we're doing association time and the time to connect to your enterprise Wi-Fi network. We don't do spectrum analysis.
Thank you.
So as the agent is connected to any Wi-Fi network, it keeps gathering metrics such as signal strength, link quality, bitrate, and BSSID, and so on, and the channel that is connected at any point of time. And you can view those in a timeline with historical do your analysis, and this will enable you to understand whether an issue, a performance issue, may be related to the Wi-Fi signal quality. And then finally, we also enable you to do ad hoc SSID scans, where the agent will return all the SSIDs in its proximity, BSSIDs, signal strength, frequency, and channels. And that way you can view in one glance to understand whether a channel is congested, so that you can adjust your configuration of the channels of your access points.
I have a quick question. On your client metrics, are you also tracking MCSs off of those? And are your clients, your sensors 2x2? So sorry, two-part question there.
Yeah, so for the MCS, we do measure MCS for the Mac OS agents, which we will cover in the next section. But in our Wi-Fi hardware sensor, we don't have that metric available. And by 2x2, what's the exactly do you mean?
Are the Wi-Fi chip that's in your sensor, is it a 2x2 chip or just a 1x1 chip?
It's a 2x2. It's Panos here.
Thank you, Panos. Any other questions? Okay, moving on. So before I dive into the demo, I'd like to first describe the setup we have for you here in our network. So we have deployed wireless and wired agents to each of our remote office locations, as well as our headquarters. Those sensors are connected to a switch, and then to the gateway router of the office. Those are being aggregated at the wide area network router level, where we have also installed a NetBeez sensor there to have more visibility over the backbone. And then in our headquarters, other than the wired and wireless, we also have a virtual machine agent deployed at the data center. Those are then accessing the internet through our internet router, where we have a couple of SaaS applications, supply chain and a CRM application. And then at the same time, we have agents on the cloud for in Amazon Web Services and on Google Cloud to get an external view of our network. So the scenarios we will be covering are proactive detection via up-down performance alerts, as well as fault isolation via incident detection. So this is our dashboard. And then as soon as you log into the dashboard, you get this bus tab view. So here we have 3 columns that you can see are the 3 main components, high-level components that we monitor. Basically, the agents are running tests continuously towards targets which represent resources in your networks. And then we also have the Wi-Fi column, where you can see the details on your Wi-Fi. And this gives you the last 24 hours view of incidents that may have been triggered in different agents, so that you can get a quick snapshot. And also here, it's a view of all the alerts that have been, the count of all the alerts that have been triggered by all the agents in your network to see which ones have a really high number of alerts, so that you can focus on those ones, again, for the last 24 hours. On the target side, you have the incidents in the same manner as on the agents. And then you have a breakdown of HTTP performance response time. So you can, again, see on a per bucket basis which targets are underperforming. And then finally, on the Wi-Fi, you have a nice table here where it shows you for each Wi-Fi network you have configured how many connection attempts passed and failed, as well as the average time to connect. So now let's go and see all these three components, how they are displayed in each of these three tabs here at the top. So first we have our agents tab, which is split into network agents and remote agents, which we'll cover in the next section. And here on the agents list, you can see all your agents that you have deployed in your offices with their types, and also some information about the way they connect to the network between Ethernet and wireless, gateways, DHCPs, as well as a real-time view of all the tests they are running, ping, DNS, HTTP, and traceroute. Green is good, orange, there is a warning, and then red is when you have a hard down alert. So looking into inside the agents themselves, just one thing here. Sorry. So this is a wireless agent that you can see here all the tests that is running to the different networks. You can see here the real-time view of the results, and here in the wireless tab you can see the connection timing, where you have the breakdown of all the past connections. This agent incidentally is also hopping between SSIDs, so you can see for each SSID how long it takes. Here are the statistics: transmission, receive rates, link quality, signal strength, bit rate, channel, BSSID, and SSID that has been connected over the past hour. And you can also view historical of these connections and disconnections to the different SSIDs, as well as the all the metrics that have been measured. And then down here we have the logs from the WPA supplicant and DHCP, where you can see in detail what's going on the agent side, on each agent, where you can filter by message string or event code and so on. And finally, the console, you basically have a direct access, direct terminal to the agent, so that you can run any type of commands that you need to troubleshoot the issues you're having. Then on the target side, here you have one thumbnail for each of the targets you have set up. Basically, these are resources in your network, applications that your users need to be able to access. And if we go into one of these targets, you can see the same test that you would see on the agent side, but here they are grouped by target. So when you click on a test, you can see the average performance over the last hour, any alerts that have been thrown, and then you can open multiple of these tests to see how they are looking side by side. Here you can set the window size for your averages. And here you can also see the jitter and MOS estimates of those of the results of those tests.
One more question for you on this. Do you aggregate and look back at the results of these tests and be able to say, over time, this was your cause was the association or the DHCP or some other issue?
So we do have on the agent side, as we said, you can see individually each connection timing, and then on the Wi-Fi side that I'm going to show now, here you have each of your networks that you have set up, and when you go inside one of these, you will be able to see on the period of time that you have selected here, how many associations passed and failed, how many authentications, and so on. But you can also get these metrics in aggregate for specific time periods through our reports or through the API.
I think I'll rephrase my question.
Mhm.
Do you have the ability to show a report to a customer that you can say, it's not the Wi-Fi, it's this? Because everyone just complains, since the Wi-Fi is the edge and it doesn't work, they blame the Wi-Fi. And I'd love to have a report that could just point the finger to where the problem really is.
Well, you can definitely run a report that shows you that it's not the Wi-Fi's problem. And then we have all the data here that you can dig in and find out where exactly is the problem and understand the root cause of the problem.
If I may dovetail on that, is there a way where you can pull trending data out of this? Does it keep it for like a year, or is it or 6 months, or doesn't?
Mm-hmm. Yeah, so you have the ability to set the data retention of how long you want to keep the data for, and then based on that, you can run all sorts of reports to retrieve that data. And of course, you can also use the APIs. Then on the test side, as I said before, we have the network bandwidth tests. So here you have agent-to-agent hyper schedule test. You have here one that runs every hour from Office One wire to the one router, for example. So you can view here the history of all the tests that have been done. So, and you can also set some conditions to mark some of the tests as, warnings, where you can see here that if the bandwidth drops below a threshold, it will be marked as a warning there for your reporting needs. Same goes for network speed and VoIP. Then at the same time, you can also view the ping DNS, HTTP, and traceroute in a grid view where you have the source and destinations, and you can open multiple tests from different agents to see what's the current performance. In ad hoc testing, you can run any of the tests that I've shown now to any target you wish. As you're doing your troubleshooting, you may want to just run a one-off test to see what's going on. So this ad hoc test tab provides that ability. We offer reports on the network status report is more of a high-level report, agent on a per agent basis, on a per target, and also on the scheduled tests. And you would see the Wi-Fi metrics basically on the agent report. In the future, we will also include Wi-Fi reports. Those are coming up. And then on the alerts tab, you have a list of all the alerts that have been triggered in the system, the source, destination, and the time, and the message, and so on. So you can search and browse through them. So going back to our scenarios, the first scenario that I will show is a induced latency on the data center link, so right here. And we will see how alerts and an incident are triggered on the agent side. So let me just go to the data center agent and run the network link scenario. So what we will notice here is that while these tests are currently showing average performance of about 50 milliseconds, you will see here that it will start growing. And I have an alert set up that if it goes above 150 milliseconds, it will trigger an alert. So while we are waiting for the alert to trigger, let me show you how anomaly detection is done on our system here. So The alert that we are looking at right now is this one here. The round trip time of a ping test goes above 150 milliseconds over a 1 minute period. It will trigger an alert. And we have different types of alerts. Up, down, down, up is a reverse alert. So if you wanted a resource not to be available to your users, but it is available, then you would receive an alert with this type of alert. Then performance baseline compares a short-term average versus a long-term average, and you can compare the two and trigger alerts if those are off. And then a performance watermark is more of an SLA type of alert. Is the one that we are looking at now, where you set a threshold where if it goes above that threshold, it will trigger a performance alert. And then you have the baseline and watermark, which is a combination of the two. So when you try to set up the alert, you choose the metric, the period, and then the comparison and the threshold you want to set. And then, so these alerts are on a per test basis. Now, if you, instead of having to notify you for every single alert on every single test, you can actually aggregate those alerts on a per component basis, agent, target, or Wi-Fi, where you set thresholds of how many of the tests on that agent, for example, need to be triggering an alert to create an incident and escalate this as a higher level event. So going back to our agent, you can see here that the performance, the round trip time increased dramatically, and we can see that all of the ping tests have triggered an alert. And we can also see here that there is an ongoing incident on the data center virtual agent. Now, if I go back, I will turn it off. And that will clear the alerts and the incident. So while we wait, I'll go through the next scenario. So in the next scenario, we have our CRM application is having periodic performance issues. And basically, we see alerts and incidents on the target. So every about 1 hour, the CRM application is experiencing a performance degradation. So if we can first see this on the bus tab, where you can see that you have all these incidents coming up every about 1 hour. So if we go on the CRM application and look at it, it is actually having this issue right now on the HTTP. And you can see these waves of alerts that are coming in from all the agents. So this tells you, before we saw an incident on the agent side, which is telling you that the problem is at the office location or the site that you're looking at. But here, in this case, the incident is on the target, which means it's an application issue. So you can see here the incidents as well that they are periodic, and tells you what are the triggering conditions that trigger the incident. And then you can also escalate these incidents through PagerDuty and by email or other integrations to notify your help desk that this is happening at the moment. And then finally, the next scenario is where our supply chain application web server goes down. We will see again alerts and an incident on the target. So in this case, the server is up as let's say the virtual machine that is hosting the server is up, but the HTTP server drops. the ping test will go through, since the network is basically able to service the packets, but the HTTP test will show a hard down alert that will denote that it's the HTTP server that is down and it's not the network. So here we can see that it's already reporting. This happened just now. So if we look at, let's say, one of the agents performing the test, we can see here that as soon as the packets start getting lost, not serviced, the HTTP requests start getting lost. The alerts get triggered and the incident is already ongoing. So if we see here on the list of the targets, we see that also the ERP application is having an incident right now.